Hey guys, welcome back to the channel. In today's TidyTuesday video, we are looking at life expectancy. And in today's video, we will be analyzing life expectancy data from the TidyTuesday dataset. We will be visualizing trends using scatter plots and line graphs. We'll take a look at the average expectancy across years and continents, and we'll try to identify countries that have significant increases in life expectancy. Then we'll finish up by creating some plots and doing some specific comparisons based on our results. So yeah, we'll be exploring a couple of new things today, and join me as we learn. And I hope you enjoy it. Okay, let's go. So in today's TidyTuesday video, the data we're working with is the life expectancy data. Let's take a look at the data is from our holding data, and we have a data set on global life expectancy. Okay, so let's take a look at the data dictionary. For this, we have three data sets. Let's explore the first one. Tuesday data for life expectancy. Okay, so what we have is the entity, the code, the year, and the life expectancy. So basically, in Afghanistan, or in the year 1950, life expectancy here was about 27.7 years, which is quite low. But as you can see, it increased over the years. So that's interesting. So for this video, I want to try to understand this progression, the way life expectancy has been increasing or decreasing across the years for different entities. I want to know which country on average has a steady increase, and I want to know which country doesn't have, and try to map them out and understand data better. So we can start with the basic summary statistic. Let's clean up this data a little bit. Okay, code is expectancy, and we have something we can work with. All right, so I for one would want to let's filter down just for I just want countries in this case. So if I look for the ones that don't have codes, we have other entities like the continent, the region, economic class, and the rest. But in the case of this example, I just want countries. Now I want to see what the average life expectancy has been by country. Entity. Okay, can we sum this up? Let's sort it. Okay, Monaco. It says Monaco on average has the highest life expectancy, with Andorra, San Marino, and the rest. Let's see if I can plot this. How do I plot this? I want to plot Okay. Well, maybe let's just skip that. Thinking about to plot this might. Let me try something. Yes. This look like. Nah. Oh. At the top we have San Marino, and well, which countries are at the bottom? Um let's use GG Repel and try to USSR, South Sudan. Wow. We have Andorra, San Marino, Ghazi, then we have USSR, South Sudan, Sierra Leone, Mali, and Cameroon. Okay, Cameroon is differ up a little bit, but countries Mali, Sierra Leone, South Sudan, and USSR. I think USSR shouldn't really be. I mean, it's no longer a country, so probably that's why it's this low. But South Sudan, Sierra Leone, and Mali are ones that on average have the lowest life expectancy across the years. Well, that helps. So what I want to do is let's take a look at, for example, uh, I'm just gonna pick the top countries here. Filter the entity in Monaco, Andorra. Let's use this too. I want to plot out their life expectancy over the year. So the first one was an average, but now I want to see the trend. I want to let's see how it progresses across the years. So make entity color. Okay, good. We want a gym line. Okay, as we can see, they have really been growing. As you can see for Andorra, around the early 2000s to of recent, the life expectancy has basically been the same, just slight progression. Then it declined, and this decline probably would be due to COVID or something, because every country had a bit of decline during 2020. Let me add one more country here to confirm. Let's use Israel. Yeah, there is this decline. So what I want to do is I want to try to understand this growth from the first point down to the last point. I want to understand on average how does it increase, by what number of years does it increase for each country. So this brings us to building a simple linear model to try to explain this data. And for now, I'm going to make an example with just one country, and we'll see how to scale it up to more than one country. So let's, I think I'm just gonna do it for the entire world. So world data. World data. Okay, so I want to let's plot this. Let's plot this against world data and see. Yeah, so there has been really interesting growth in across the world. Life expectancy back in the day was very low, and now it's quite high. We can model this result and see on average how it increases across the years. So what we want to do is a simple linear regression, model. We want to model the life expectancy on the year, passing the data, world data. Now, so what this result is telling us is that for the coefficients of year, as the years increase, the life expectancy is supposed to increase on average by 0.23 years. So that's about 0.2308 times 12. Increases by about 3 months or so. And that increase is what has led to this across the years. We can present the results in a more tidy format. We have the estimates from here and some other statistic like the p-value, which tells us if there's a relationship between the predictor and the response variable. So is year a good predictor of the life expectancy? As you can see, it's quite a good predictor. And the estimate here, it shows that there is some relationship, and we can see that as the years increase, life expectancy is supposed to increase on average by 0.23 years. So now we want to do this, but not just for one model. We want to do this for every country. So for us to do that, we need to nest the results. We need to do this in a tidy way, of course. And for us to do that, we take the data we're working with, then nest it. So what I want to do is to nest. I want to nest year and life expectancy. So as you can see, for every entity, we have a small table that talks about, that has records for each year and each expectancy for that year. So we take this result and we model it. So we are going to pass in this function, but in a slightly different way. So what do? We map it. So we map data around our function, which is lm. I'm just going to copy paste this. And instead of world data, we use .x. So, this x variable. So we run that, and you can see for every entity, we have a linear model that explains the progression for each year. So what we next need to do is to tidy the results. So we create a new column called res tidy, and again map it. Each model we want to broom tidying, and for each model we have a tidy format which just contains the intercept and the year variable coefficients. So we wouldn't be using the intercepts in this case because for our case they don't really translate well and we don't need that. But what we need is the coefficients for the years I want to understand the growth. So what we can do is to select the columns that we really need. I need the entity, I need the rest ID, and we can unnest. Then I also would filter out where term is supposed to year. Okay, now for each year, we've basically summarized the trend, so the growth per year. So on average, for the country Afghanistan, life expectancy increases on average by 0.5 years. So that's about 6 months, half a year. And for Algeria is about 0.6, which is slightly above half a year. So we want to see which countries have it most and which countries have it least. Now for the p-value, p-value also shows if there's a significant relationship between the estimates between these values and the response variable in this case, which is life expectancy. So a strong p-value, which a very low score, means there's a very good significance, there's a very good relationship, and high value means the relationship isn't really statistically significant. So we will be plotting the estimate and the p-value on a scatter plot, which would tell us some more information, and we have some confidence that our results, we know where they fall. If it's a high value but doesn't really have strong p-value, we kind of know that it doesn't have a strong p-value, but it's not statistically significant. So let's do that. In order for us to do that, we need to adjust the p-value. So we adjust, adjust. So basically we adjust the p-values for multiple comparisons. We have a number of comparisons, so we adjust the p-values and we can plot. So let me save this data. Life expectancy model, and let's plot this out. So plotting this, I want to ggplot. I want to plot p-value on the x-axis. I want to plot estimates on the x-axis, p-value on the y-axis. Okay. I want labels to be entity. I want points. Okay, what's going on? Every value is on okay. Let's put this on the log scale. Y log. Okay. All right. Let's gem text repel. We can, yep. So we have a pretty good value. We probably want to mark different points. Say geom y line intercept 0.05. Let me see. Okay, I don't think there's any point of doing that. Okay, let's do it this way. So let's clean up the plot a little bit. Labs x is p-value, y is estimate, title is average increase in life expectancy by country. Let's the nice theme. Okay, this needs to be swapped. Okay. So it's alpha. Would also be nice to have colors by continent, I think. So I need to figure out the way to attach continents to this data. So I want to attach a continent to the countries. So we use the country code package, which helps us attach continents, as new column. Then we can use that to finalize the plot and plot these points. So the dot represents, the color of the dot represents the continents in which the countries are located in. So as we can see, a lot of Asian countries have had like quite high increases on average across the years. Then a lot of European countries have had somewhere, somewhere in the middle. So the growth hasn't been so much on average. Year to year, the growth hasn't been so much. Then a lot of African countries are just spread across. So at the far end of the spectrum, we have a lot of African countries like Zimbabwe, like Lesotho, Eswatini, and Zambia. Somewhere in the middle, we have countries like Rwanda and South Sudan, and somewhere at the far end, we have countries like Gambia, Morocco, Egypt, and Libya. So let's try to see how how the trend looks like. So we'll pick a country that is on the far end, country that's on the far right, the far end on both sides, that is low values and high values, and somewhere in the middle. So we use Oman, Zimbabwe, and Sweden, and we try to see the trend. So for Sweden, the plot, remember we're looking at average growth year to year. So when we look at the yearly growth, hasn't really, although from the start to the end there's significant growth, but on a year to year basis it doesn't grow exponentially. It's basically goes up and it comes down, but at some point it begins to kick off. This trend is quite different from the trend of Oman, which just kept moving, and also different from Zimbabwe. Zimbabwe's trend is it never really left a zone. It peaked at the point and went down, and also went back to that same peak, and it's looking like it's going to go down. So that's the reason why the values are low. It doesn't necessarily mean that um the estimates that are in the middle don't really do well. They probably would do well, but as you can see for Sweden, the trend shows that um, at at a good period of time, it was basically hovering around a particular area, but steadily it began to increase. But as it was increasing, there was still dips along the ways. Those dips cannot be found in the trend of Oman. Oman just kept going, and that's the reason why the estimates for Oman were that high. So we tried to summarize a lot of data for different countries using a simple model, and created a plot to um, have a bird's eye view on how countries perform. We started with a simple summary statistics by getting the average um, expectancy for the years, and we try to model the data and see how those expectancy grow year by year. So at the end of the day, we tried doing a simple linear model on just one data, and later we scaled it up to run different models on a whole bunch of data. So yeah, that's a very simple approach on how to summarize large data and get quick insights to your data using a simple statistical model like this linear model. And yeah, that's it.